Okay, so the first thing that I would do tomorrow is set up my unit circle quickly. I would do degrees, so I would add 45 to get to all the halfway points. 90 plus 45, we get 100. We get 135. 180 plus 45, we get 225. 270 plus 45, we get 315. Then I would go up and down 15 from the blue center. So I would get 30. 15 more than 45 is 60. 15 less than 135 is 120. 135 plus 15 is 150. 225 minus 15 is 210. 215 plus 15 gets us 240. We get 300 here, and we get 330 here. So you spin around and do the degrees really quickly. Okay, so then I would fill everything out in the first quadrant. I would fill out the cos and the sine, see all those ordered pairs, and then I filled out all the tan values. Obviously everything in quadrant 1 is positive because we're going to the right and up. And tan is sine divided by cos, so positive divided by positive is positive. Then I'm going to loop around and do the ABC thing that I taught you. So notice I loop around and I go ABC, CBA, ABC, CBA. So then what I do is I go to each quadrant and I remind myself what cos and sine should be, whether it should be positive or negative. So as you see, in quadrant 2, I reminded myself cos is negative, sine is positive, right? Because to the left is negative and up is positive. And the tan must be negative because sine divided by cos, or positive divided by negative, is negative. And I did the same thing in quadrant 3 and quadrant 4 to remind myself what the answer must be. Now that I'll have all this set up, I can do all the problems quickly. I'm sorry, I just laugh a little sometimes. Okay, so for number 1, when it says what's the cos of negative 240, what I do is I always like going to the positive values and then working backwards. So what I do is I spin around the circle to positive 240, and then I say to myself, okay, how many times did I hit one of those tick marks, so to speak? So at 30 degrees, I count that as 1, 45, I count that as 2, 60, I count as 3, 90, I count as 4, and so on and so forth. So 5, 6, 7, 8, 9, 10, 11. I went 11. So now I'm going to go in the reverse 11. So now I'm going to go this way 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And if I do that, I end up landing on 120 degrees. So 120 degrees is technically the same spot as cos negative 240. So I know the answer, cos negative 240 is the same spot as cos 120. So what's the cos of 120 degrees? Well, I look at the 120 degree spot and I see that I labeled it as letter C. So then again, we go to quadrant 1 where we labeled everything. I look at C. And if I'm looking for cos, cos is on the left. So cos is 1/2. But then we go back to 120 degrees and we have to say, is our answer 1/2 going to be positive or negative? And in quadrant 2, cos is negative, so I'd have to say negative 1/2. So my answer is negative 1/2. So for number 2, it says, what's the cotan of pi over 3? So first, I prefer to work in degrees. So I converted pi over 3 to degrees by multiplying by 180 over pi, and you get 60. So you can ask yourself, what's the cotan at 60? So we need to go to 60 degrees, and again, I always like working with sine, cosine, and tan. So when I go to 60 degrees, I'm right here. That's the spot I'm looking at. But I'm going to work with tan. So at 60 degrees, the tangent is root 3. But since we're talking about cotan, we need to do the reciprocal of that. So we would go 1 over root 3. We rationalize by multiplying by root 3 over root 3. And our final answer is root 3 over 3. So cotan at 60 is root 3 over 3. Or cotan at pi over 3, same thing as root 3 over 3. Okay, so for number 3, I just got it set up. It says the tan of 3 pi over 2, which is the same thing as tangent of 270. So I looked, and that's the point right here, which is the ordered pair 0, comma, -1, where we know 0 is cos, sine is -1. But then if tangent is sine over cos, I did sine is -1 divided by cos is 0, and so that's undefined. So our answer for number 3 is undefined. Okay, so for number 4, we see secant of 7 pi over 6. So I first convert 7 pi over 6 to degrees. I prefer working with degrees, and I know it's 210 degrees. Now, when you go to the unit circle, we need to work with sine, cosine, or tan. So the reciprocal of secant is cos. So we're going to go to the unit circle, and we're going to look for the cos of 210 degrees. And going to what I said before, if you go to the cos 210 degree spot, if you notice up top, it says letter A, and we know letter A corresponds with root 3 over 2 comma 1/2. So we know that cos at that spot, for that A spot, is root 3 over 2, and we have to decide based on the quadrant, is it positive or negative. So let's see, in the third quadrant, cos is negative. Now that's not going to be our answer because this represents cosine at 210. And if we want secant, we have to flip it because we're talking about the reciprocal secant. So let's flip negative root 3 over 2. Okay, so when I flip, I get negative 2 over root 3. I have to rationalize, so I have to multiply by root 3 over root 3. So then my final answer will be negative 2 root 3 over 3. That's the secant of 7 pi over 6. Or the secant of 210 degrees. Okay, so for number 5, they say what's the cosecant at 570 degrees? So we first need to think, okay, wait, what's its reciprocal? What's the sine at 570 degrees? Now 570 degrees isn't on the unit circle, right? It's 0 to 360. So we have to keep spinning until we hit 570 degrees. So if you take 570 and then you minus 360, that means you're going to do 1 revolution. You would have 210 remaining. So essentially what that's saying is you do a full loop. I did that in yellow, that's 360 degrees, but to get to 510, we need to add 210 more. So the yellow is 360 plus 210, we stop right there. That is 570 degrees. So you're really looking at the 210 degree spot. And the sine at 210 is, let's see, at 210 it's an A, so sine's a half, so it's going to be negative a half, right? So the sine is negative a half, but because we're working with cosecant, we have to flip negative a half. So it's negative 2 over 1, which is negative 2. So sine of 13 pi over 3 is the same as sine of 780 degrees when you do a conversion. So we're obviously going to loop around more than once. So I look at 780 degrees and I go, okay, let me loop around one time. So I'm going to subtract 360 degrees. And then we would have 420 degrees. But that's still more than 360, so we're going to do another revolution. So we subtract 360 again, and we're left with 60 degrees. So for 780 degrees, for the sine of 780, we're really looking at the sine at 60 degrees. And the sine at 60 degrees is root 3 over 2. Okay, so for problem number 7, we first need to look at what they give us. They tell us tan of theta is 5/9. So that means tan, they're telling us, is positive. And they say cosine is less than 0, meaning cosine is negative. All that this information gives us, it helps us determine what quadrant our triangle is in. So if it's all students take calculus, we first think about tan has to be positive. Okay, so if tan's positive, quadrant 1's in the running. If tan is positive, quadrant 2 is out, because only sine and cosecant are positive. If tan has to be positive, quadrant 3 is still in. And if tan has to be positive, quadrant 4 is out, because only cosine and secant are positive there. We then look at our second restriction. So if cos has to be negative, and we're between quadrant 1 and quadrant 3, cos has to be negative. It's got to be in quadrant 3, because cosine is negative here. Only tangent and cotan are positive. So we're going to draw a triangle in quadrant 3. So I like to first draw my triangle, and I like to put theta right here. I like to set it up. Remember, theta is between the terminal side and the x-axis, and I know that opposite is across from the angle, the hypotenuse is across from 90 degrees, and the adjacent is on the x-axis right now. So now I'm going to find the values. Well, in the beginning, they told us that tan of theta was 5/9. And you know tangent is TOA, opposite, over adjacent. So we then look at this triangle, and we're going to label the opposite side 5, and we're going to label the adjacent side as 9. Now, before, if they just said tan theta is 5/9, they weren't considering that they then were going to throw in a restriction, putting this triangle in the third quadrant. And due to that second restriction, we need to go, oh, we're actually moving to the left, so this needs to be a -9. Oh, we're going down, so this needs to be a -5. So you gotta think a little after you put your numbers in there. Should they be positive or negative? Now we're gonna do Pythagorean theorem to find the hypotenuse. So then you do Pythagorean theorem, and you find that the hypotenuse is square root of 106, and that's it. We can't simplify. Square root of 106. Okay, so using that triangle, if sine is opposite over hypotenuse, we look at that triangle. The opposite is -5, and the hypotenuse is square root of 106. Then we look at cosine, that's adjacent over hypotenuse, so the adjacent is -9 over the hypotenuse, square root of 106. Then we look at tan, opposite over adjacent, so the opposite is -5 over -9. Then I'm just going to flip all those values for their reciprocals on the right side. So when I did that, on the right hand side I flip. Now notice for tan and cosine, they're double negative, so the answers are positive, so it's just positive 5/9 for tan and 9/5 for cotan. And then for sine and cosine, you need to multiply both of them by square root of 106 over square root of 106, so I'm just going to write the simplified answer. So after rationalizing for sine and cosine, our answers are over here.